Good morning, students. Myself, Dr.BADI ALEKHYA, Associate Professor, Department of Artificial Intelligence and Machine Learning, R.M.D. Engineering College. Today, we are going to discuss one of the important concepts in test processing, edit distance. So, what is edit distance? Mainly it is used to find out the difference between the two strings and compared with basic operations, insertions and deletions and substitutions to transfer that string into another form. So it's mainly used in spell checking, text correction, and machine translation and speech recognition applications. So here today we are going to discuss one of the edit distance mechanism, Levenstein distance. It is used to finding the distance between the two strings, and also based on the distance it is going to convert that string into another forms, which form we are needed. For that edit, it is using three basic operations. One is insertion, deletion and substitutions. So here insertion we are adding, deletion removing and substituting, replacing one character with another character. So here we consider two strings, kitten and sitting. Kitten, under kitten the K is substituted by yes, and it will insert I at the E's place and then add G at the end to convert that word sitting. Totally three operations. How this manually calculated things will be implemented in mathematical form? Let us discuss with the matrix representation. So here it is the example. We have two strings, A sitting, B kitten. So I am considering kitten and sitting in a matrix form, and I am considering the rows like this. If you observe here, so I am starting from index 0, 1, 2, 3, 4, 5, 6, 7 and kitten index KITTEN. Then I am starting my string after this null value 1, 2, 3, 4, 5, 6. I am starting my string after this null value 1, 2, 3, 4, 5, 6, 7. Let us start the procedure. We have three rules for solving the Levenstein distance. Row is not equal to column means we have to consider three elements around the matrix, replace, remove and insert. Among these three elements, which one is minimum? That minimum of that element plus 1. If row is equal to column means just copy the diagonal element to the corresponding box. So let us see the calculation. Initially we have these things only. Now let us solve the problem with 0, 1, 1. Now I want to calculate this one. How this work will come here is among these three elements, replace, remove and insert. Among these three elements, which one is minimum? 0 is minimum plus 1. That means how I am going to replace with 1 means I am going to check with character S with K. When I am checking character S with K, S is not equal to K. At that time I have to apply the rule. Row is not equal to column. Row is not equal to column is what's the rule? We have to calculate minimum of replace, remove and insert plus 1. And then move to the next representation. I have 1, 1, 2 with me. I have to calculate this value. How I can calculate S with I. X is not equal to I. Again a minimum of this thing. 1 is the minimum plus 2. Again I am going to compare x with 3 like that. Among these three elements 2 is minimum plus 1 3. Among these three elements 3 is minimum plus 1 4. Like that, if row is not equal to column, you can replace with what condition? We have to consider minimum element among the three elements and then you can add plus 1. Now come to the second condition. I compare I with K. I have three elements with me now. 1, 1, 2. Among these three elements, because I is not equal to K, then rule is minimum of these three elements plus 1. Minimum of these three elements is 1, 1 plus 1, 2. Now I am going to compare I with I. This is second condition to get I is equal to I, row is equal to column. Then you have to apply rule. You have three elements in your hand. 1, 2, 2. What is the rule of all row is equal to column? Just copy the diagonal element. Now 1, 1, 2. What is the diagonal element? 1. 1 is directly copied here. Again I with t not equal to minimum plus 1. I equal to t not equal to minimum plus 1. Like that it is repeated. We will get totally 3 operations at the end. How you are going to apply backtracking here is two rules. One row is not equal to column. Among these three elements, which one is minimum plus 1? If row is equal to column, just copy that elements to the diagonal box. At last, we are getting three operations to make the string kitten is equal to sitting. So, when we are applying backtracking, we can also check that whether our answer is correct or not. How three operations is there means. Now I am checking G with N. So not equal to, then here I need some operation. One operation I am going to use here. Again I am going to check the arrow marks you needed. Again I am going to check, and within again I need an operation of it. I can replace. Where you are going to get the arrow mark, that place you have to check whether your answer is correct or not. So I have to add at the end G, and I can substitute instead of K. I have to substitute yes, and after that instead of E I have to substitute I. So totally three operations are needed to convert the string kitten to sitting. This is the way you are going to calculate the 11th distance problem. That's all students for the today's session. I will meet with some